Alright, this video is to help you in your homework tonight. We're going to find an inverse of a function. The first thing we need to do is graph it and use the horizontal line test to see if in fact it will have an inverse. So we'll draw some axes. I recognize the form of this particular equation happens to be a line with a slope of -3 and a y-intercept at -1. So we're going to graph f of x on the y-axis. Okay, y-intercept at -1. My slope is -3, so I can go down 3 and over 1, or I could go left 1 and up 3. Okay, either way. And I see I have a line that looks something like this. It's not the best line ever drawn by man, but it's okay. And now I'm going to use the horizontal line test. In fact, it surely passes. Now I happen to know that any line other than a horizontal line is in fact going to pass the horizontal line test. That's okay. So this thing should have a function. F of x, should have an inverse function. So the first thing we're going to do after we graph it and it passes the horizontal line test is I'm going to change f of x into y. Okay. Notice that this graph is the same as this. Y equals -3x minus 1. That's this graph. It's just when we're talking about functions, we use function notation. For algebraic reasons, though, to make things a little easier, we're going to change f of x to y, rewrite the equation. Next thing we're going to do is swap x and y and solve for x. Okay, so now I'm going to have x, because I'm changing them around, equals -3y minus 1. Now I need to do some algebra to solve for, this should be y, solve for y. Alright, so let's see, I'm going to add 1 to both sides. I get x plus 1 equals -3y. Now I want the y all by itself, so I'm going to divide by -3. That leaves me with x plus 1 divided by -3 equals y. Okay, which I'm going to rewrite neater form, -1/3 x minus 1/3. Okay, I can do that because I can divide the denominator. If the numerator has two parts, we have a single denominator, I can rewrite this piece of the equation as a mixed number. It has two different numbers. Okay, the next thing I'm going to do is replace y with the f inverse symbol of x. Okay. Now I have an equation that I think should be the inverse for this one. So I have a function, f inverse of x being the inverse of in other words, -1/3 x minus 1/3 is the inverse of -3x minus 1. Okay, I'm not done yet though, because what I have to do is make sure that the domain of f, okay, so all x's I can put in here, is the same as the range, all the outputs from my inverse. Okay, and I also need to make sure that the range of f, all the outputs, is equal to the domain, everything we could put in my function here. Okay, let's graph this just for fun. -1/3 x minus 1/3 happens to have a y-intercept at -1/3, be about right there, and a slope of -1/3. Let's see, rise over run, so down 1 and over 3. Same as going up. Go up 1 and left 3. Okay, so our line looks something like this. Okay? Now, what we happen to know about lines, linear equations, is that we can put any real number in here, and for any line that's not horizontal or vertical, our range is also going to include all real numbers. Because we're going from -infinity on the x-axis, as we go out toward -infinity, our y value is going to increase. As we go out toward positive infinity, our y value is going to decrease. So we know, because these are lines, that they in fact have a domain and a range that is all real numbers. Therefore, if the domain, all the inputs, is all real numbers, and the range is all real numbers, down here the same is true. All our inputs are real numbers, include all real numbers. Our output includes all real numbers. Then we know we're good. Okay. The last step, we're still not done. We need to show that the composite function f of f inverse x does in fact equal x, and we also need to show that f inverse of f of x equals x. Okay, so let's do that. F of f inverse of x, okay, we have to find our f function, so it's going to be -3 times whatever we're plugging in minus 1, okay, which is going to be -3. What are we plugging in? We're plugging in f inverse of x, which is this equation here, -1/3 x minus 1/3. Okay, so let's distribute this out. -3 times -1/3 is 1. So 1 times x is x. Okay. -3 times -1/3 again is 1. So we have x plus 1. That's the result of distributing the 3 into what's in the parentheses. We still have the minus 1. It was x. Awesome. Okay, let's do the same thing with this one. Now we need to make sure that f inverse of f of x is also x. Well, what's f inverse? Down here. So it's going to be -1/3. Now x is going to change. I'm going to change it in parentheses and put whatever we're plugging in. I still have the -1/3 here. Okay. And this equals, let's see, what is f of x? Well, let's see, f of x is -3x minus 1. So I have to distribute this in. -1/3 times -3 is 1 times x still. And then -1/3 times -1 is just plus 1/3. And I still have -1/3. Let's clean this up. 1 times x is just x. 1/3 minus 1/3 is 0. There we go. Okay. Now I've completed the 5 steps to proving here's our inverse function to our given function.